Ever since I was a young sapling, I've had a mind filled with ideas. In fact, if I took this time to present to you all of the ideas that I've had, chronologically speaking, from the time I was a little girl until now, I don't think any of us would be getting any sleep. In fact, when I was 7, I had the idea of transferring the consciousness of our imaginary friend into a body of a robot in a humanoid form so that they could assist us and make us happy and follow us wherever we went. And as I grew older, my ideas began to surround modern day issues such as the water crisis. So when I was in grade 7, I thought, why don't we just create water if there's such a huge shortage in water? Now, that reaction would be highly exothermic, combining two hydrogen atoms with an oxygen atom, but it's an idea that still comes around to my head till this date. But I have noticed there is one thing, one single element that ignites within us, that causes us or inspires us to go ahead and venture off into exploration. And in my theory, it's the art of storytelling. Now, I am absolutely ecstatic and obsessed with science fiction films. They engage me in scientific controversies and make me question about things and their possibilities of occurring, such as the movie Martian, where the protagonist is forced to live on Mars due to some unprecedented situations. So it makes me wonder, is this truly possible? And that's exactly what I want to discuss here today: the physics behind Hollywood. Take this moment to think about the one thing in all of sci-fi Hollywood that has been repeated so many times that it has kind of become a genre of its own, a cliche of sorts in science. For me, that would be time travel. So that's what I want to discuss here today. The concept of time travel in movies, but on a much more scientifically accurate note. This is exactly why I want to take in account one of the more recent pictures called Tenet. Now, in Tenet, the concept of reversing entropy essentially being the thermal energy per unit temperature that is unavailable for doing useful work in order to reverse time itself. We dive into the unique concept of matter and antimatter in this film. Now, let's take it this way. There's a mouse that is moving forwards in time, and he goes to a turnstile, which is essentially the time capsule in the film. And now that he went to the turnstile, he's now going backwards in time. Now, he would be experiencing time quite differently compared to when he was moving forwards in time. What is hot, and what is cold for the mouse that is traveling forwards in time according to the thermodynamic equilibrium. But when now he's going backwards in time, the thermodynamic equilibrium has reversed. So now what is feeling? Being hot for the mouse that is traveling forwards in time is now cold for the mouse that is traveling backwards in time. Taking all of this into account, we are taking in as well as breaking the laws of quantum mechanics. And you must be thinking, Dua, what's all of this for? What am I going to be gaining out of this? And I want to teach you the possibilities of time travel through this movie, because I have learned the possibility of time travel through this movie. According to Wheeler's delayed choice experiment, it is possible to go back in time. Bizarrely speaking, all the laws of physics except for the second law of thermodynamics have no preference in the direction of time, meaning you can go forwards or backwards without breaking any laws except for the second law of thermodynamics. Now, when our little mouse or the characters in Tenet are moving backwards in time, they are said to be antimatter of sorts. That's why they are fully covered with masks on. These masks supply them with anti-oxygen. There is one misconception though. If I were to go back in time, I cannot change what is occurring, because for me, it had already happened. I can do things that are yet to be finished off. Okay, let's say that I have found a glass of water at this very moment. 50 years later, I figure out how to turn back time and come to this moment. The only thing I can do is place a glass of water here. I cannot change the fact that I might drink soda or iced tea. But in the chance that this does happen, another very exciting theory in physics comes into play. This is also seen in another very cool set of movies, such as the MCU, the multiverse. The many worlds interpretation has been coined by Hugh Everett in 1956, and he states that there are multiple different realities where we have made different choices. And we can see this with the help of the Schrodinger's cat experiment, which is a thought experiment. In Schrodinger's imaginary experiment, you place a cat in a box with a tiny bit of radioactive substance. When the radioactive substance decays, it triggers a Geiger counter, which causes a poison or explosion to be released that kills the cat. What do you think happens when you open the box? Is the cat dead or alive when you open it? The cat is actually both dead and alive. But by the time you open the box, you are consciously measuring what is being seen in front of you. Hypothetically, let's say I have lifted up the box and the cat is alive. This measurement collapses the probability waves of the cat being dead and alive until a peak value of the cat being alive is present only. But according to Hugh Everett's theory, there's another universe where this cat would have been dead. Which means in another universe, I would have been explaining this to you in some foreign language if the circumstances were different. Or maybe I might be getting an A-star in physics for this project. The possibilities are endless. And this is what is seen in the TV series Loki. This is where Loki interacts with multiple versions of himself from a different timeline. In fact, there's a psychological repercussion called the Scully effect. And Dana Scully, a character from the X-Files in the late 90s, she was portrayed to be a strong woman in STEM. And this, in fact, had inspired 60% of the women in STEM who knew this character to go into STEM and pursue it in the first place. And it's so mind-boggling how a single character, how maybe many years ago the writer was just writing about this character, this woman in STEM, this female in STEM. And now, many years later, maybe the nurses that we see in the hospital or the doctors that are now neurosurgeons or operating on us, they're probably there, or I mean not probably, they could be there because of a film character. So the idea of future storytellers or filmmakers, everyone taking STEM and accurate scientific representation into account, it could be so inspiring for the future generations. If there are any future filmmakers or storytellers or writers in this audience at the moment, then I urge you, please, accurate scientific representation can create a generation of people that are so focused in STEM. It is so mind-boggling how just the power of your words and emotions and excitement seen within a film or within a piece of writing can inspire so many people. So be kind with your words, use them nicely, and use them to empower other people. And this is what film has done for me. It has empowered me to be, very excited about things like quantum mechanics, astrophysics, and even about neuroscience recently. So it's so exciting how the thrill and the possibilities of STEM can make life feel like a movie. Thank you.